So let's start this tutorial with this question. What happened to the dinosaurs? You might think you know the answer to this question, but actually, this question is what we call a black box question. A black box is anything we cannot directly investigate, and there's a couple of reasons why you might not be able to directly investigate something. In the case of the dinosaurs lived so long ago that nobody was alive to see them, so we can't go back in time and actually record what happened. But that doesn't mean we can't study them. Scientists do not believe that the dinosaurs became extinct because of smoking, although that is a cute idea. The reason that dinosaurs died off, we think, is because of a collision with a meteor, which sent a dust cloud into the atmosphere and blocked out the sun for a long period of time. And since these big reptiles really needed the sun to basically live, they slowly died off. At least that's the thinking that we currently have. But there's no way for us to actually know what's inside that black box. It happened in the past. We can't travel back in time. We can gather evidence to support the idea that the dinosaurs were killed off by a meteor, but we'll never know for sure. We can only gather more and more evidence to support the idea. Here's another example of a black box. This is a diagram showing what we think the inside of the sun looks like. So we can see the sun from this distance, but we can't actually travel to it. Not only is it too far away, but it's extremely hot, so it would be very dangerous for us to go to the sun. And yet, we're able to make these detailed diagrams explaining how we think the sun works and what we think's going on in that distant ball of gases that are on fire. How do we do that? Well, this is another example of a black box. It's a black box because we can't directly investigate the sun because it's too far away and it's too dangerous. But we still can gather information. Here's one more example of a black box. These are pictures or diagrams of what we think atoms look like. And you can see that what we think an atom looks like has changed over time as we've gathered more and more evidence about atoms. Here's the thing though. Even today, with the modern technology that we have, we really can't see the structure of an atom. It's too small. We don't have devices that can see things that small. So you might be wondering, how do we even know that atoms exist if we can't see them? Well, atoms are a black box. They're too small for us to investigate directly, but we can gather evidence indirectly. So I keep talking about indirect gathering of evidence. The lab you're going to do in class tomorrow is about gathering evidence when you can't directly observe. Here's the top of your lab sheet. It's a little bit messed up in here because I transferred it from my Dropbox, so the formatting's not quite as nice as your formatting will be. You're going to access this probably through Google Classroom, but potentially you could also have a hard copy. So the lab is called 1A, the black box, and the purpose is to figure out how the black box works. And your black box is actually a box that is colored with a question mark on the front. Here's the hint I'm going to give you. You need to get your box working in order to figure out what it does. And there are some hints about how you might do that. You're going to read the directions. When you get your box, it'll come with a set of directions which tell you the things that you can and cannot do. These boxes can actually easily be broken or damaged, so you really need to follow the directions because they're not easy for me to fix. You're going to form an initial hypothesis, but only after you get the box working, because there's nothing to hypothesize about until you figure out what it does. Then, after you get your box working, you're going to sketch out a drawing of what you're thinking at that moment might be how your box works. Chances are you're going to be wrong, but that's okay, because science often progresses like this. You start out with a hypothesis, you test out that hypothesis. If it doesn't work, you change it. After you develop your hypothesis, you're also going to want to include something called a rationale. Notice how the word rationale actually has an E on the end. I'll show you what I'm talking about right here. It has an E on the end because it's not the word rational, it's the word rationale. A rationale is a noun, and it's a noun that means your explanation of your thinking. So when you form a hypothesis, it's important that you also provide a rationale which explains why you think that's what's happening. So you're going to explain yourself. You're going to say, well, the reason we came up with this hypothesis is we saw this. Then your next step is going to be to perform experiments to test your hypothesis. And this is really important. You're going to want to try and figure out what procedures can you do? What procedures can you do that allow you to test out your idea? So here's the question you have to ask yourself. Whatever your idea is, say, okay, if this is true, what can I do that will show me that it's true? And then you want to write what the plan is in this box here. So you might write, we're going to jump up and down 3 times in front of the box. I don't know why you would do that, but let's say that that's what you're going to do. Then you're going to record what happens when you do that. That's your data. That's what actually happened. Now, the trick to doing this well is to figure out good procedures that lead you to answers. So you can't just be randomly trying everything with your box. You really have to plan it out carefully. Always ask yourself, what is it that I'm trying to find out by doing this? What information is it going to give me? Because if you're not careful, you'll run a whole bunch of tests and know nothing at the end. After your group has spent some time collecting data about your box, you're going to go home that night and you're going to draw a picture of what you now think is how the box works. You're going to draw a picture basically of what you think the inside looks like. And that picture will explain your observations. So the whole point of the picture, which is really a model, right? You're going to draw a model of what you think the inside of the box must look like based on your observations. You're going to make it very neat. You're going to label anything that isn't obvious. Then you're going to answer these simple conclusion questions. So you're going to describe how your drawing explains your observations, and you're going to answer this question, is there anything that you observe that you can't explain? Then down here in the second question, you're going to tell me how confident you are that your picture is correct. And it's okay. This is your confidence level. I want you to be honest. You can say 1, I'm not confident at all that this is what's really going on. 10, 100% I'm confident that this is definitely what's going on. And then I want you to try and explain to me what gives you that level of confidence. What is it that makes you feel so strongly one way or the other? And then down at the bottom is kind of running out of room. This question asks you whether or not your hypothesis has evolved or changed over time, and if so, what made you change it? So it should change over time because as you gather new evidence, your ideas should change. We're only going to spend 1 day or so experimenting with our box, but it's important to realize that real black boxes can take centuries to fully investigate. So just look at this little flow chart. Start up here. Right, here we are. In 1665, somebody invents the microscope, this guy Robert Hooke. And that allows us to see, for the first time, these tiny little organisms that we had no idea were there. Then, in 1668, this guy Francesco Redi provided evidence against the idea that disease was just spontaneous, that it came from nowhere. Then van Leeuwenhoek discovered microorganisms with the microscope. That takes a little while. And then in 1835, we get this guy who comes up with the idea of germ theory. He says he thinks that silkworms, which are actually the worms that produce silk, he thinks that they're dying off because of a fungus that's killing them. And then, on and on it goes, little by little, more discoveries until finally, sometime in 1854, almost, close to 200 years later, finally, the cholera outbreak of 1854, which is a disease that we don't really deal with anymore in this country because we've eradicated it. This guy, John Snow, figures out that, I think that this stuff is traveling through the air. It took a long time to realize all of that. And that black box took many, many years of lots of different pieces of gathered evidence. We don't have that kind of time, so we're doing a much smaller problem. We're using a simple little box to try and figure out how do scientists figure out what's going on when they can't directly investigate. Okay, let's review real quick. Could you pause the tutorial and define the term black box? Try it and then see what the definition really is. Did you remember? A black box is anything we can't investigate directly. And there's a couple of reasons why you might not be able to do that. For example, it might be that the box or whatever it is, the object, is too far away, like the sun. It could be that it's too small, like an atom. Or maybe it's too dangerous, also like the sun. Or maybe it happened too long ago. In our case, the reason that we have to investigate our box indirectly is because I have locked the box door, so you cannot open it. So that's kind of an artificial black box. Although sometimes things that were black boxes at an earlier time in history become not black boxes anymore because suddenly new technologies make them so they're not too far away. Or new technologies allow us to be able to see things that are that small. Or new technologies allow us to investigate despite the dangers. Or a new technology maybe someday will come along to allow us to go back in the past. I somehow doubt it, but it could happen. Okay, see you guys in class.